Okay, Ruth said yes, is a co-host. Alvin, can you go then? Okay, Mr. Ronald is still having some challenges, but Alvin Faith is our first presenter. So Alvin Faith, can you take all the floors as we wait for Mr. Ronald to make other presenters co-hosts? So Alvin Faith, take the floor and you start the discussion. She's going to be taking us through set theory and logic.
Mr. Kaziba, you can let me know who the other presenters are so that I can.
Oh. We have Nisima Christabella. We have Christabella, so you can raise up the hand. Nisima denies, Christabella and Jemima and Luther. So they can raise up the hand and you make them co-hosts.
Okay.
Okay, over to you, Alvin.
Good afternoon to all of you. I am Alvin Faith. Naigaga. Okay, I'm Alvin Faith Naigaga, Senior 3. I am going to take you over set theory. Yeah. Okay, as our number one went as, if number of elements in set A is equals to 60, number of elements in set B is equals to 48, number of elements in set C is equals to 63, number of elements in number of elements in set C is equals to 63. Number of elements in A intersection B is equals to 21. Number of elements in A intersection C is equals to 24. And number of elements in set B intersection C is equals to 15. They are also telling us number of A union B union C is equals to 120. So they are asking us to find the number of A intersection B intersection C. And I had to let it to be X. I had to let the number of A intersection B intersection C equal to X. Now, as we have our X as an intersection, we shall fill in our Venn diagram depending on our question. So here we have number of elements in A is equals to 60. As represented here, this circle here represents those in A. So they are telling us that the whole of this circle here is equals to 60. They're also telling us number of elements in B is equals to 48, meaning that this whole set here is equals to 48. And they're also telling us number of elements in C is equals to 63, as you see it here. So we have filled in our Venn diagram depending on our question, but we still have some other questions. Some other elements in our question. So they are telling us number of A intersection B is equals to 21. So we have to come back to our Venn diagram, look for where A is and look for where B is. Now they are telling us that their intersection, those in the intersection of A and B. So their intersection is here, the midpoint of A and B. That is 21. But remember, this 21 also has the intersection bit of it all. So we shall have 21 minus the intersection minus the X, where we shall end up with 21 minus X. We get back to our question. We have number of A intersection C is equals to 24. So we shall look for where A and C is here. So we have our A here and we have our C here. So in that case, we shall have our midpoint here. But remember, we have been given 24, but 24 has the bit of X in it. So we shall have 24 minus X. Yeah, we go on with our question. Well, we have number of B intersection C is equals to 15. So here we come back to our Venn diagram, look for B and C. So our intersection is here. We end up with 15 minus X. We end up with 15 minus X for our intersection of B and C. So we still have another one here, which is telling us that number of A union B union C is equals to 120. That is our intersection. Just a moment, let me type it here for you. That is number of, okay, the intersection is giving us 120. So that's what? That's for the not intersection, for the union set, the universal set. So they are telling us to find the number of A intersection B intersection C. That is our X here. But remember, we don't have this, we don't have this, and okay, we don't have those for A only, we don't have for B only, and we don't have for C only. We shall go ahead and calculate for A as the first. So that is 60 this minus into 15, no, minus into 21 minus X plus 24 minus X. If we come back to our expression here, we have this minus X plus X, which will give us a 0. So we shall end up eliminating this and eliminating this. We shall end up eliminating this and eliminating this. So we shall remain with 60 minus into 21 minus X. So if we are going to open brackets, we shall end up with 60 minus 45, minus 21 plus 24, which gives us a 45. So that is 60 minus 45 plus X. Many of you may be asking me why I made it a plus X, yet in our bracket, we have a negative X. But as we remember, we have a negative out of the brackets. And here we are opening up brackets. So we had a positive 45, which when we multiply with a negative 1, we get a negative 45. That is a minus 45. Then the negative X times a negative X, you all know we make it a positive. That is a plus X. If you get this expression, 60 minus 45 into your calculator, you end up with a 15 plus X. You come back to your Venn diagram and fill it in as it is. So we can go ahead and work out for B only. That is 48 minus into 21 minus X, and 15 minus X. But we still have a plus X minus X. So that is like a plus 1 minus 1, which gives us a 0. We end up eliminating those two, giving us a remainder of 21 plus 15, which gives us a positive 36 minus X. So we open up that is 48 minus 36 plus X, giving us a 12 plus X as our expression for B only. So we go ahead and calculate for C only. Since we are looking for the union, like generally the whole, so we have to fill in all our gaps in the Venn diagram. That is 63 minus into 24 plus X, plus 15 minus X, a plus X. So that is giving us 63 minus into brackets 39 minus X. So if we are to open up our brackets, we shall remain with positive 39 minus x. So when we open up our brackets, we shall end up with 63 minus 39 plus x, ending up with 24 plus x. Do we have any questions up to that point?
Alvin, we can continue.
Okay, then. Let me first erase this. So we are going ahead to find our x. If we are to find x, since we have our universal set as 120, we shall add up everything in our Venn diagram. That will be 15 plus x plus 21 minus x plus 12 plus x plus 24 minus x plus 24 minus x plus this x plus 15 minus x plus 24 plus x, which gives us a 120. So here we shall collect like terms. If you are to collect like terms, we shall look out for the x's, we put them alone, and also the numbers, we put them alone. So we have a plus x here and a negative x. Eliminating that, giving us a 0 for that. Then a plus x here and a negative x here. Still eliminating that, leaving us with a 0. Then a plus x here and a minus x. Still giving us a 0. Leaving us with 15 plus 12 plus 24 plus 21, a plus 24, and then a plus 15. If you add them up, you end up with 111. You end up with a 111 and plus x, which we did not eliminate, which is giving us 120 as our total. That is x is equals to 120 minus 111. That is x, which is equals to 9. So as we look through our question, in our question, they did not give us an x anywhere, but remember, we let our x be that. So if we let our x, our number of A intersection B intersection C be equal to x, that means we shall come back and conclude that number of set A intersection B intersection C is giving us 9. Yeah, and we have answered our question.
So in case you have any question, you can raise up the hand. You can raise up the hand. I think Nesima, Jemima, they are going to make you cohorts. Okay, Shona.
Yes, could you repeat that explanation, but using the Venn diagram?
Okay.
Where exactly?
Use the Venn diagram to like get the answer, because I'm seeing like so many numbers. I can't tell which one is how to get it. Yes, use the Venn diagram. That one.
Okay.
Thank you.
Okay. Alvin, first take on that question and answer.
Okay, as I told you, this is our universal set, which is giving us a 120. But this universal set is carrying on the quantity of the whole of this set, the way you see it here. So this is telling us that the whole of this set here, the whole set, all that of A, B, and C, the universal set is equals to 120. So if we are to add up 15 plus X, 21 minus X, 12 plus X, 24 minus X, plus 15 minus X, plus 24 plus X, it should be giving us a 120 in total. So we have to equate this, equating it with the set. That's why I said we have to add up everything. That's why I said we have to add up everything. We have to add up everything. 15 plus X plus 12 plus X plus 24 plus X plus 21 minus X plus 24 minus X plus 15 minus X, which is equals to 120. Since it is equal, like all this expression here gives us an equal rate to this 120. Yes.
Okay. Okay. Mrs. Kasamba, you have an input.
Okay, thank you very much, Mr. Kaziba. I'd like to thank Alvin for her presentation. I just want to add something little. Now, the previous person asked a question, how do all those elements, I think she's seeing so many things, 24 plus X and what? Just to add on, Alvin, it's very important that when we have the 3-Venn diagram, we always start from the center. So now that center, I don't have the diagram, that center is now catering for the intersection of the 3 sets, A, B, and C. So we always start from there and then we move outwardly. Now, in the information given, the intersection of the 3 sets is not known. That's why we should now start by saying, let the number of elements that belong to all the 3 sets, A intersection B intersection C, be X. Thank you for that screen. Then afterwards, we move outwardly. So after you have entered that X, you move outwardly. I think that's what the previous person was asking. So now you go to the information given, you start with the intersections. We have the number of elements that belong to set A and B at 21. So you have A and B, 21, but you've already fixed the X, implying that those, I don't have my screen, those who do not belong to A and, those who belong to only A and B only will now be the 21 minus X. Then you move out to another intersection. I can now go to the intersection of A and C. You've already fixed the X. A and C, according to the given information, we have 24. Now, to fill in that other thing which looks like a triangle between A and C, how do you fill it in? A and C comprises of 24 elements, but you've already entered the X in our Venn diagram. So filling up that other region, which we say members that belong to A and C only. Now that's when we deduct the X from the 24. And that's how the 24 minus X comes in. Then you also now move to the other extreme right, the other intersection. So, which was given us, the one which intersects B and C. They've given us that the elements in B and C are 15. Now you've already entered the X, so you need to fill up that smaller X. Already you have, the total should be 15. Now you deduct those who belong to the 3 sets, leaving us with 15 minus X. Now, Alvin, I came in at the moment when you are now filling in the onlys. So now you enter the elements that belong to set A only, set B only, and set C only. So you do it step by step. So what you have on your extreme right, according to my screen, what I'm seeing, where the pointer is, we are now, I think, looking for elements that belong to A only. Now, the whole of set A already has 60 elements or 60 members. Already you have the 21 minus X, the X, and the 24 minus X. But that entire set should be 60. So that's why Alvin was now laboring to show you how we get the A only. Thank you very much. My A only, which she got as 15 plus X. How did she get that? The entire set should be 60. So you can say maybe Y, A only is Y plus 21 minus X plus 24 minus X. That should give us 60. The same to B only and then C only. Maybe to throw out what Alvin was trying to explain. Because the question is not talking about the universal set, we keep quiet about the universal set and we use the information given. Now they are telling you that the number of elements that have all either A or B or C, which write as a union set, is 120. So that as Alvin was explaining, the union set is the whole of that. So that's why she adds up whatever is in those small regions, that should now add up to 120 to help her get the X. I don't know if my input has been understood, but thank you very much, Alvin. And thank you very much, Mr. Kasva, for the opportunity.
Thank you so much, Ms. Kasamba. Mr. Arthur, can you make Mrs. Kasamba co-host, as well as Martin, Nisima, Jemima? Okay, Jemima is already a co-host. Okay. Okay. I'm seeing some hands up. Technopop 4, can you first rename yourself? Rename yourself, then we shall be able to give you a chance to ask a question. Okay. Yes, Alvin, we can continue to the second number.
Okay, thank you. Okay, let me read this question for you. It is saying, in a recent talent show contest on BBS TV, that 98 people in the audience were asked to vote as many of the 3 contestants, A, B, and C, as they wished. 20 people voted for B only, and the same number voted for C only. The number of people who voted for all the 3 contestants was the same number of people who voted for both B and C, but not A. Allow me first explain that. So they were telling us the number of people who voted were 98. That is our universal set. They're telling us the number of people who voted the universal set is equals to 98. They're also telling us that 20 people voted for B only and the same number voted for C only. The keywords here are the only. It's the only bit of it. Let me try do this. Okay, this is the keyword here, because without it, you cannot get what it's meaning. So they're telling us 20 people voted for B only and the same number voted for C only. So if we get back to our Venn diagram, they're telling us 20 people voted for B only. The B only is the B only is here. And they're telling us the very number of people voted for C only. So meaning that if 20 people voted for B only, also 20 people voted for C only. So they're also telling us the number of people who voted for all the 3 contestants was the same number of people who voted for both B and C, but not A. So we get back to our Venn diagram, and let us say, let the number of people who voted all the 3 BX. So let us say, let the number of people who voted for all the 3 contestants be X. So if that is X, this is telling us that our universal set is equals to X. Is equals to X. So if that is equals to X, our question is telling us that the number of people who voted for all the 3 contestants was the same number of people who voted for both B and C, but not A. That is telling us that those who voted for all the 3, okay, the number who voted for all the 3 is exactly the same as those who voted for B and C, but not A. That is meaning it is it's in our intersection for B and C, but eliminating the A part of it. So this is showing us that this whole thing, this is out of that expression. It is telling us that the intersection of B and C is just exactly as the same as the general intersection, but without the A. That means our second X is going to lie here. It's going to lie here, where the intersection of B and C are. So we get back to our question and look through it once more. It's telling us the number of people who voted for all the 3 contestants was the same number of people who voted for both B and C, but not A. And half as many as the number of people who voted for A and B, but not C. So let's, since we are done with the portion of, those who voted for B and C, but not A, let's first eliminate out of our question. So the question is telling us that the number of people who voted for all the 3 contestants was as half as the number of people who voted for A and B, but not C. That is showing us that in the intersection of A and B, there lies a number that when you multiply the intersection, it will give you the answer. So it's telling us that actually the general intersection, the number of the people who voted for all the 3 is just half of the number of people who voted for A and B. So that this is telling us that the intersection of A and B without C is twice X. Yeah, we are done with the intersection bit of it. So here, when we get to this point, we get back to our question, which still reads that the contest was won by A with 48 votes, meaning that the contestants who voted for A were 28. Then those who voted for B were 40, and those who voted for C were 34. Standing in our Venn diagram, we have our number of A outside of the set A, which is equals to 48, number of B, which is equals to 40, and number of C, which is equals to 34. So when we get to this point, we have two methods to reach to the answer. Now, you can either decide, okay, don't look at this and this. Without looking at this point and this point, because we don't have it in the question, but getting to this point, we have the whole of this set. So this set can actually lead us to finding our x. But if you're not well conversant with this set to give us your x, you can as well go ahead and find 34, and find those for A only and those for A intersection C only. So you go ahead and find them. If you are well conversant with the B set, we shall go ahead and find our x directly without finding the 34 minus x and 14 minus x. So if we go ahead and use our B set, we shall end up with the x plus 20 is equals to 40. Okay, let me do it on the other side. Okay, we shall go ahead and find these. Okay, remember we have the whole set for B is equals to 40. So meaning if we use that 40 for this set, it will give us 40. So that is to say we shall have our 2x plus x plus x plus 20, which will be equal to 40. So if we are to collect like terms, we shall end up with 4x, which is giving us 40 minus 20 if we are to collect like terms. So that is giving us still 4x, which is equals to 20. If we divide all through by x, we shall end up, if we divide all through by 4, we shall end up as our x, which is giving us 5. So in such block questions where we still have something to go ahead with, we come back and what? We actually have to come back and fill in our Venn diagram. So using the expressions we have below, or we have above, we shall end up with a 5 as our x. Our x we were given as 5, according to how we have calculated it using this. I'm going to still calculate using the whole set, but let's first finish up with that of B. So if we end up with 5 as our x, we shall have 5 for our intersection. We shall still have 5, since they told us that the number of those who voted for all the 3 is equal to the number of those who voted for B and C, but not A. So we shall end up with 5 still here. We shall also come back here where they told us that the number of those who voted for all the 3 is half that those who voted for A and B but not C. So remember we put here our 2x. So we shall get our 2 times x here, and we end up with a 10. Yes, still in our expression, we have 20s ones already given. We have we are given the 20, we just place it there, then also this 20. Now we are going to go ahead and find this 4 here. So if I'm to find that 4, I will come back still and say 34 minus into 20 plus 5 plus 5. Remember, this set is supposed to give us 34, but if we are to subtract what we are given, we shall be able to find what is not given. So this is giving us a 34 minus a 30, which is giving us a 4. So you come and input the 4 here in the A intersection C. So since we have got a 4 here, we shall end up and we shall come back and find also this 29. Remember, we were not given in the question up there. So we shall come back and find the number of those who voted for A only. Those who voted for A only, we shall still come back and find them, which will tell us that 48, those who voted for the whole A, like voted for A completely, minus into 29 plus 10 plus, no, the 29 is out of it because we are just finding it. That is 10 plus 5 plus the 4. That is giving us, this is giving us 48 minus, let me see, that is 19. If we input this, we shall end up with 29. So you come and fill up your Venn diagram. You shall have a very complete Venn diagram at this point. So I humbly request that I go also work out the other formula together with you, then we can go ahead with the question. So we have, okay, we don't have A only and we don't have A intersection C. So we shall go ahead and find them. That is to say, that is, okay, we are finding this first because it's going to help us. It's going to help us find the A only. So we shall first find A intersection C only. So we shall get our 34 for the whole C. Since we are given these 3, we are given x plus 20, but we don't have one of that in the set. But remember, they gave us the whole set is equals to 34. That will be 34 minus 20 plus this x and plus x. So that is 34 minus 20 minus x minus 2x. Still here we shall have to collect like terms. Okay, here we collected like terms. This is how we did it. This is 34 minus into 20 plus 2x. So this is how we collected the like terms. So if we are to open up the brackets, we shall end up with a 34. Remember, we have a positive 20, but outside we have a negative 1. So if we are to multiply a negative 1 times a positive 20, we shall end up with a negative 20. That comes out to be a negative 20 plus still we have here a negative 1 and still a positive 2x here. So that will be minus 2x. Day 14 minus 2x. Okay. Yes, this is what we are ending up. So we have here A intersection C only as 14 minus 2x. Now this is going to is our work to find A only. And A only, we have already 48 here. So we shall get our 2x plus x plus 14 minus x. Still, in our expression ahead, we shall work out. So I pulled out, that is 48 minus into 14 minus x plus 2x. So I still collected like terms. And remember, as I told you earlier, we have a negative 2x plus x. It's just telling us 2 minus x. No, 2 minus 2. That is giving us a 0. So we end up eliminating this and this. So if we are to collect like terms, we shall have a 48 minus into 14 minus x. No, it's a plus x. Yes, it's a plus x. The remainder is a plus x. So yeah, we shall remain with that. So in our expression, we shall end up with a 48. If we are to open up brackets, that will turn into a minus 14, then minus x, ending up giving us a 34 minus x. So we have a 34 minus x here. So since we have filled in our Venn diagram, we shall go ahead and find our x. And that is to say, we shall start with x plus another x here. We have x plus x, then still plus 14 minus 2x here, then plus 2x. Oh, sorry. Plus 2x. Okay, now all our intersections are, we have filled in all our intersections. Like we have inputted them here. So we shall go ahead and also input those for the outer. That is to say, oh, let me repeat that. That is x plus 2x plus 14 minus 2x plus 34 minus x plus 20 plus 20. So as we know, this should actually give us, this expression should actually give us a 98. So that will be actually equal to 98. So if that is equal to 98, we shall still collect like terms. Now, let me help out and eliminate some of these. So we shall eliminate this plus 2x with a negative 2x. That is 2 minus 2. That is a positive 2 minus 2, giving us 0. We still have a negative here, so we shall still eliminate this with that. Yes. Then we shall remain with an x. We shall remain with an x, then collect the like terms for the, just a minute, what is 14 plus 34 plus 20 plus 20. So we still have, let's see. Okay. We have our x plus a 93, giving us equal to 98. So this x ends up giving us a 5. Yeah, so whichever method you use, you end up getting the same answer. So if we have to get back to our question, if you get back to our question, they're telling us part A, draw a Venn diagram to illustrate the data. So if we have drawn our Venn diagram and actually we have finished up with illustrating the data on it, then part B is telling us determine the number of people who voted for all the 3 contestants. So here, for all the 3 contestants, remember we let it be our X here. So once you find X, you have found those who voted for all the 3 contestants. So you go back and say our part 1, so X is equals to 5. So since X is equals to 5, therefore, number of those who voted for all the 3, is equal to 5. So if that is equals to 5, you have to what? You have to conclude your answer so they can get to know that, yeah. But if you let it in at the beginning that let the number of those who voted for all the 3 be equal to X, then you can leave it at X is equals to 5. So we're still going on with our question. It's still telling us determine the number of people who voted for at least 2 of these contestants. Now, at least 2 means 2 and above, at least 2. So their list number is 2. So that is 2 and above. So we shall get back to our question, now to our Venn diagram. At least 2 is 10 plus 5 plus 4 plus 5. Since these ones voted for 1, the 29, 20, 20, these guys only voted for 1, but these ones voted for 2 and above. So these ones here, the 10, 4, and 5 voted for 2, and these 5 voted for 3. So that is, so when we end up calculating the 10 plus 4 plus 5 plus 5, we end up with 24. We get back to our question, which is telling us, determine the number of people determine the number of people who are refrained from voting. Let me see. Yeah, determine the number of people who are refrained from voting. Now, the number of people who are refrained from voting, this is how we are going to get it. Remember, we have 98 people in our universal. So we are going to calculate our whole union and find out if 98 is actually equal to what is in our Venn diagram. So that will be 29 plus 10 plus 20 plus 4 plus 5 plus 5 plus 20, which is giving us 98. So let me add what? An unknown here. Let us call it, let me see. Oh, let me call it A to find out if it's actually equal. So that is 20 plus 5 plus 5 plus 29 plus 10. 29 plus 10 plus 20 plus 4, giving us, wait, let me do that again. 20 plus 29 plus 10 plus 4 plus 5 plus 5 plus 20, giving us a 93. Actually, we are having our A is equal to 92. 93. Oh, no. A plus 93 is giving us 98. So this is actually showing you that our union has 93 people, but all those who voted were 98. Now, so it means, okay, I think we should make our this an A, our those who did not, who are refrained from, okay, those who did not vote, actually. That's what it's meaning, that those who are refrained from voting, those who did not vote, if it is A. So it's showing us that our union set, let me show you where the union set is. This whole set here has 93 people, but they are telling us the number of people who are in the voting place, 198. So this is actually telling us that our A is actually giving us 98 minus the 93. So still A is equals to 5. So it means those who did not vote are actually equal to 5. Yeah, as I said here, yeah, those who are refrained from voting are equal to 5. So can we get back to our question? We still have one question to go, which is telling us if the voter is picked at random, and what is the probability that he or she voted for only one of these contestants? So only one of these contestants, we have 29 plus 20 plus, we have a 29 plus 20 and plus 20. So this will give us the number of events. Remember, probability is equal to number of events out of number of sample space. So number of events is got by those people who voted for only one. So if we add up 29 plus 20 plus 20, we shall be able to get those who voted for only one, and that is 69. So that is 69 as our number of events, and number of sample space is 98, since all those who voted were 98. Thank you for listening. Any questions?
Those having questions, please go on and raise up the hand. Moira, it seems you have a burning question. Ankonda Moira, can you go on and unmute?
Yes, teacher, I wanted to ask. Yes, teacher. Teacher, I wanted to ask Alvin about how she got the X using the Venn diagram. I didn't get her explanation clearly.
The what? Pardon?
How you got? I wanted to know how you got. Okay, I wanted you to pardon me on your explanation on how you got X using the Venn diagram.
You mean the X here?
Yes.
This X in the intersection, or the X in this B intersection C?
The intersection.
I think, Alvin, we need to stick to the first way you solve for X than the second way, because
okay.
the second way where you wanted to use everything in the Venn diagram, you were skipping out the bit which is outside. So the only way you could approach this one is to start with the set B to find X, and then fill in the others, and then you can now find the missing number. Okay. So let's not take the approach of using the whole set. It gives you the same value, but the approach lacked the outside element.
Yes. Okay, if I'm to answer her question, she's asking where I got the X. As I started explaining, I said I let I said I let the number of those
to catch up on time, Alvin, you could just use the Venn diagram than typing so that we don't go back to a lot of time.
Okay, I let the number of those who voted for all the three be X. So since I said that, okay, those who voted for all the three is the intersection set. So the intersection set is equals to X.
I don't know really whether the question has been answered the way you wanted. I'm not getting her, but Vivian, can you ask? Vivian, unmute and ask.
Yeah. So, like, I'm not getting how she got that 2x for A intersection B, and also, like, how she got 14 minus 2x for A intersection C.
Okay, Vivian, let me bring you back to the question, how I got the 2x. It is telling us the number of people who voted for all the three contestants was half as the number of people who voted for A and B, but not C. So this is telling us that these people, the number of people who voted for all the three contestants was just half of those who voted for A, of those who voted for A intersection B only. So that means that this A intersection B only is twice the number of those who voted for all the three contestants.
Okay, about 14 minus 2x.
How about the 14 minus 2x?
Yeah, because I don't remember being it in the question, but they gave us A intersection.
Yes, yeah, they did not give it to us, but we have 34 for the whole x. We have 34 for the whole x. So for the whole set of C, this, yeah? And remember, we were given x, and 20. So if we equate this x, 20, and this unknown set, it will be able to give us a 34 in return. So we shall get a 34 minus into 20 plus x, which will give us a 34 minus 20 minus 2x. So if we work it out, the 34 minus 20 will give us a 14 minus 2x.
Oh, okay. Thank you so much.
Okay, can we have Shilat? Oh, okay, Shilat, your mic is off. Can we have Rashida? Rashida, unmute.
I wanted to ask about the third question. Are you hearing me?
Yes, go on.
Alvin.
I'm hearing you.
The third part, I did from voting. The third question refrained from voting. First, please repeat it for me.
Those refrained from voting, yeah?
Yeah.
Okay. As I said, the union set has 98 people. So if the union set has 98 people, we shall have to find out if this whole set actually has 98 people. But when we calculated 29 plus 10 plus 20 plus 4 plus 5 plus 5 plus 20, it actually gave us 93 people. So since it gave us 93 people, it means our union set has 93 people, but still there are these people who did not vote, who are being included in the universal set. So we shall get our 98 minus the 93 we have for the whole set, giving us a 5 in remainder, meaning that these 5 people are the ones who did not vote.
Okay, thank you.
Welcome.
Let's have one more question. Miracle. Miracle, you can unmute.
Thank you so much. My connection was in and out, but may you please help me with the other first Venn diagram that has a sketch of the answers. I got quite confused. Yes, that one.
This one?
I got
Where
quite
did you get
confused.
confused?
Yes, please.
Where? Exactly.
Not number one, number two. The first Venn diagram, number 2. Yes, that one. Okay, I got lost on how you got the number of members in set A only and set A union. Set number of members in set A intersection C.
Okay, we are not going to actually use them. I just found them because I wanted to also use the second method, but we have been told to stick on the first formula where we used B only and the set of B. So if we are using set of B, we actually don't need this A and A intersection C. But
my question was, how did you get them?
How I got them? I first found A intersection C. So this A intersection C, we have 34. We have 34 for C, but 34 were given X 20, but this was unknown. So to find it, remember that will be the equal. 34 is the equal for the number of people in the whole of set C. So that is 34 minus 20. No, that is 34 minus into 20 plus x into brackets. So that is 34. If we open up brackets, that is 34 minus 20 minus 2x, which gives us a 14 minus x at the end of the day. So we shall have 14 minus 2x at the end of the day for our A intersection C only. So after finding that, we go ahead and find for A only, and we have 48 for the whole of A. So we shall get in and say 48 minus into 14 minus 2x plus x plus 2x. So we have plus 2 minus 2, which will give us a 0. So we shall end up with 48 minus 14 minus x, which ends up giving us 34 minus x.
Oh, okay. Thank you so much. And one final question.
Yes,
now when they said that the number of members, the number of people who had all the 3 was half as many as the number who voted for both A and B. I thought that would be X over 2. But
Not
instead...
Okay, so this is what the question said. The question said the number of people who voted for all the 3 contestants was half as many as the number of people who voted for A and B but not C. So they are telling us those who voted for all the 3 contestants was just half of those who voted for A intersection B but not C. So this A intersection B but not C is 2x. So yeah, that's it.
Okay, thank you so much.
Okay.
Thank you so much, Alvin, for the presentation. Please, you can shower her with some flowers using the chat. Thank you so much, Alvin. Those who have questions, yes, Mr. Abraham.
Now, Mr. Stephen.
Yes, you can go on. Mr. Abraham, you are not clear. Mr. Abraham, you are not clear. Probably let's use the chat. Mr. Abraham, Teacher Abraham, the network probably is not clear, but we can as well use the chat such that we can add in our input. Okay, allow me to go to the next presenter. Thank you so much, Alvin. You can now stop sharing the screen. Our next presenter is going to be is going to be Luther Bukenya, and is going to be discussing for us proportions. Luther, you are welcome, and please take on the floor.
Okay, thank you. Now, I'm going to handle number 19 under ratios and proportions. The question says, the cost C of a roll of cloth is partly constant and partly varies as the square of length L of the cloth. Now, from that, that's where we get our first, that's where we start from. The cost of a cloth C partly varies. Now, when they say partly, it means it will have 2 parts. So I prefer to write C1 plus C2. Now, partly varies as a constant, meaning C1 is a constant. Let's name that first constant. Of the
Are we losing Luther? Mr. Ayuba, are you able to hear Luther?
No, I'm not able to hear him. I think he's having a challenge. We'll give him a minute.
Okay.
In the meantime, as we wait for him, okay. I have clicked the link for the mathematics course, which I've posted in the chat room. If people could just click that link for those who have never managed to enroll, it will automatically ask for the enrollment. In the chat room, I've put a link. You can, the one that starts with help.sc, it goes straight to the mathematics course, and then you enroll as we wait for.
I think, okay, so please use the link to register such that you will be automatically added to the system. As we wait for Arthur to come back, can we be having Jemima? Arthur, are you back?
Yeah, I'm back.
Okay.
Okay, so I was saying, we had said C1 is a constant. We had said C1 is a constant, which we are giving K, and C2 varies as the square of the length, so it's L squared, meaning C2 is equal to, now we need another constant here, and I'm going to let our constant be M. C2 is equal to M, the length squared. So from that, we get that the cost of the cloth partly varies as a constant and as a square of the length. Now we go to the second part of the question that says, if the cost of a roll 50 meters is 50,000 and the cost of a roll that is 80 meters is 96,800, part A says form an equation. So we can't form an equation when we don't have the constants. So that's what we'll have to work out for first. They said the cost of a roll 50 meters is 50,000. So cost 50,000 is equal to K, which is our first constant, plus M, and the length squared. We found out that the length is 50. So 50 squared. And the second part says the cost of a roll length, 80 meters, is 96,800. So 96,800 is equal to K plus M, and the length is 80, so 80 squared. So what we see from this is that we have now formed, we need to get K and M, and we are going to use simultaneous equations. Since we have formed two simultaneous equations, the first is 50,000 is equal to K plus M, 50 squared, and the second is 96,800 is equal to K plus M, 80 squared. So you can use any type of method to solve the simultaneous equation, but me, I decided to use the elimination method. So I'm first going to arrange them in an order that I feel comfortable, which is K plus M 80 squared is equal to 96,800. And then the second equation, K plus plus M 50 squared is equal to 50,000. Then you can decide to leave the squared as they are, the squares as they are, but me, I'd like to work them out from here to avoid further complications. So I'll come again and say K. My next step will be K plus 80 squared is 6,400. So 6,400 M is equal to 96,800. Then the second one is K plus 50 squared is 2,500. 2,500 M is equal to 50,000. So now, elimination method, you'll have to eliminate one, and I've decided to eliminate K because it's the easiest to eliminate. So you come aside and say you subtract here. And when you subtract, it will give you K minus K is 0 plus 6,400 minus 2,500 M will give you 3,900. So 3,900 M is equal to 96,800 minus 50,000 is 46,800. So now we have 3,900 M. 3,900 M is equal to 46,800. Now, when you divide both sides by 3,900, so that you get M as 12. So that's the first constant we have got. Now, you use this, you substitute it in any equation here, and I've chosen K plus M 50 squared is equal to 50,000. So K plus M, which is 12, times 50 squared, which is 2,500. Sorry. Plus 2,500 is equal to 50,000. Okay. Plus 12 times 2,500 is 30,000. Is equal to 50,000. Meaning, so when you subtract 30,000 on both sides, you get K is equal to 20,000. Now that's our second constant figured out. So our first constant M is equal to 12 and K is equal to 20,000. So I don't have space. Let me write it up here. So we substitute these values into this equation, which is C is equal to K, which is 20,000, plus M, which is 12, L squared. So that's the answer for the first part, which was form an equation that relates C and the length L. That's the answer. Does anyone have a question before we move on? No? Okay.
Okay, there are some questions, Luther. Let's first take some questions. Yes, Sarah?
Could he change the color to a darker color? Because I can't see the things that he has written out.
Okay.
I can't see them properly.
Okay, thank you, Sarah. Abdu?
Okay.
Abdu, unmute.
Yes, actually. I've already finished to unmute. Yeah, my question is that as he said that C1 is a constant, I got confused on where he said that C is equal to K plus M squared. So I don't know how we made it from there.
Beg your pardon?
Luther is asking, where did you get K plus ML squared? Can you pardon him? That's how you got there?
Okay. First I said, in the question they said partly, meaning C has two parts, C1 and C2. Now we see that partly constant is C1, so C1 is equal to K since it's constant. And C2 varies as the square of L. So C2 varies as L squared, right? Meaning C2 is equal to ML squared, right? Now we have our C1, which is equal to K, and our C2, which is ML squared. So we use them to substitute them in this. C1 is K and C2 is ML squared. So I came down and wrote it again as C is equal to K plus ML squared. Does that answer his question?
Yes, it is fine. Can we have Joy?
I just didn't understand where the M came from, that's all, but part of my question has been answered.
Okay, good. Okay, yes, Martha?
So for me, I'm totally lost. I got a problem with my network. Then I don't know which number we're on.
We're on number 19.
Okay, Arthur, can you also go on and help them where the M has come from? How you are.
Okay,
Tell them what M is.
M is a constant. In variations, in proportions, if they say C2 varies as L squared. In order to write it with equal signs, you have to get a constant. And I chose my constant as M. You can use any letter you want, B, X, but me, I chose M. So C2 varying as L squared is the same as saying C2 is equal to my constant, which is M L squared. That's where the M came from.
Okay, look, I think we can go on to part B. You can have a new share and we get another board.
Let me just erase.
Okay.
Yeah.
Mr. Ronald, could you share the questions again? So those who don't have the questions, they are going to share them in the chat. We are on number 19, ratios and proportions. So Mr. Ronald is going to share the.
So number 19B says calculate the cost. Part number 19B part 1 says calculate the cost of a roll length 20 meters. So we are going to use this equation everywhere. That's the use of the equation. That's why I've left it there. We need it to calculate the cost. So if C is equal to 20,000 plus 12,000 L squared, that means C is equal to 20,000 plus 12. Now they require us to find the cost of a roll which is 20 meters long. So 12 times the length 20 squared, meaning C is equal to 20,000 plus 12 times 20 squared is 400. So we go ahead to say C is equal to 20,000 plus 12 times 400 is 4,800. Meaning C is equal to 24,800. And since it's the cost, it's in shillings. So that's our answer for part B, part 1. Any questions?
Luther, I think we shall take the questions at the end.
Okay. So part 2 says calculate the length of a row which is 24,700 shillings. So we again use this. We again use that equation, and we go ahead, say C is equal to 20,000 plus 12L squared. And since they're given us the cost as 34,700, put it here. We substitute 34,700 is equal to 20,000. In order to solve, we have to collect like terms in order to solve this equation. So 34,700 minus 20,000 is equal to 12L squared. So in order, I prefer to put the 12L squared the other side to make it easier to solve. So you just exchange the position and say 12L squared is equal to 34,700 minus 20,000. Which, so 34,700 minus 20,000 is 14,700. Is equal to 12L squared. So you divide 12 on both sides. L squared is equal to 14,700 divided by 12, meaning L squared is equal to 14,700 divided by 12 is 1,225. So in order to get L, you have to remove the square, meaning you find the square root of L squared. And what you do on that side, you must do on the second side. So you find the square root of 1,225. Meaning our length is the square root of 1,225, which is 35 meters as our length. Okay, I'm done. Any questions?
In case you have any question, raise up the hand such that Luther can be able to unpack. Okay, yes, Lillian?
Thank you, Rosa. My question is, where did we get the 20 in L squared?
The question said calculate the cost of a roll, which is length 20 meters.
Okay.
And we already, okay. So when you substitute, L is 20, yeah.
Yes.
Okay. Okay, I think it is clear. Gran?
Yes.
Gran, unmute.
My question is, I would like him to repeat for me the explanation of Roman number 2, where there is the length of a row, the last number.
Okay. They said calculate the length of a roll, which costs 34,700. So we first get our equation and we substitute. Since they have given us the costs, we say 34,700, which we have substituted for C, is equal to 20,000 plus 12L squared. So we collect like terms and say 34,700 minus 20,000 is equal to 12L squared. So me as myself, I prefer to take the unknown to this other side to make it easier to solve at the end. So we just exchange the positions and say 12L squared is equal to 34,700 minus 20,000. And when you work it out, 34,700 minus 20,000 is 14,700, meaning 12L squared is equal to 14,700. So you divide both sides by 12 so that you get this unknown alone, meaning L squared is equal to 14,700 minus 12. L squared, sorry, 14,700 divide by 12, meaning L squared is equal to 1,225. When you get the square root of L squared, it's L, and the square root of 1,225 is 35. Next question.
I think it's okay now, Dran. Then Tasha. Tasha. Tasha, unmute.
My question is, I wasn't available. I wasn't there with the computer. I didn't know the question. I only see the answers.
I haven't. Have you gotten the question, Luther?
No.
No.
Tasha, we beg your pardon?
I don't have the question. Some confused. Then I can understand by the question.
Okay, Tasha, you are not clear. Can you use the chat and type in your question? Can we have Christine?
Thank you for the permission given to me. Me, it's not a question. Actually, my network was jumping. So I didn't understand from he started everything like up to 35 meters. So I asked that he may re-explain.
Mr. Kaziba, we would like to, I think we better go back and show the students where they will be finding all these recordings plus also the other materials, because we cannot do much in just 1.5 hours here, but we can do much in the week within the e-learning platform. So I suggest that we conclude on Bukenya's presentation. And if Mr. Ayub is still there, let's go back to the platform. Even if people are not registering, at least we show them where they have to find all these materials and how we shall be using that space.
Thank you so much, Luther, for the presentations. Christine, Geet, and Rashida, could you please type your questions in the chat? We are going to be able to answer them, and the teachers are available. They are going to answer them. Thank you so much, Luther, for unpacking for us the question. We can show him some love by showering him with some flowers. Mr. Ayub.
Hello.